In Precalculus 2-3, we're dealing with the remainder theorem. So we're going to start factoring equations and bigger equations, equations that we couldn't really do with the methods we tried for last section. So they're going to give us a factor, and then we're going to finish it from there. So for example, 2x minus 5 is a factor, right? If it is a factor. So we have to check. And just like we're doing, 30 divided by 3. 3 is a factor of 30 because when I divide it, I get a whole number. If I get a decimal or a remainder, then it's not a factor. That's what I have to check, because I have to divide this to see if I get a remainder. So I have, we're going to use long division. And anything missing, I put in for a placeholder 0. So 3, 2, and I'm missing an x. So plus 17x squared plus 0x, and then, oh no, there is an x. But if there wasn't, I put it as a placeholder for 0. Just a reminder. 4x plus 60. Right, so this is long division. So from here, I focus on the first number, 2x into 6x cubed. And so I have to multiply this by 3x squared. And I start here because I have two terms, so I'm going to end here. So 3x squared. So 3x squared times 2x gives me 6x cubed. 3x squared times negative 5x is minus, 3x squared is minus 15x squared. And then I subtract. 17 minus a negative 15 is 17 plus 15, which would give me 32x squared. And then I bring down this, negative 104x. So then I'm going to manipulate to here to here. This is 8x, right? Yeah. So positive 8x. So 8x times 2x gives me, no, sorry, it's not 8, 32, sorry, 16x. So 16x times 2x, which would give me 32x squared, and then 16x times negative 5, Miss P's not thinking straight, 16 times negative 5 is negative 80x, and I'm subtracting. And then, so from here it's negative 104 minus a negative, which is positive. So 104, negative 104 plus 80, which would give us negative 24x. And then I'm going to bring down a 60, plus 60. So then I focus here, which then gives me a negative 12x. Negative 12x times 2x is negative 24x. Negative 12x times negative 5x gives me a positive 60. No, sorry. I don't have to have that x, right. So then I subtract. And so we do, these is 0, and this is also 0. So because this is 0, this is yes, it is a factor. Okay, if it was anything else but 0, it wouldn't be a factor. Now, if I went through that pretty quick, it's because long division, synthetic division, we learned in Algebra 2. So if you need a more slow-paced understanding, go to my Algebra 2 page and look up long division, synthetic division. It should be in the later chapters on that page. So go ahead and pause and write this down. This is long division. We're going to also do synthetic division and compare the two. So number 2 says divide this by this. Now, our options are, I can do long division, which we do 3x plus 2 divided by 9x cubed. I'm missing a squared, so plus 0x squared minus x minus 3. And I would do the same process to here. Sorry, 3x to this squared would give me, I needed to multiply it by 3x squared. This gives me a 9x cubed. And then 3 times 2 is a positive 6x squared. And then I subtract. So 0 minus 6x is negative 6x squared, and then I'll bring this down. So minus x. So from here, I then need to change this, so I need negative 2x. So negative 2x would then give me a negative 6x squared. Negative 2x times plus 2 is negative 4x, and then I subtract. This is 0, and then negative 1 minus a negative, so it's plus 4, so negative 1 plus 4 is 3x, and I'm going to bring down the negative 3, and so we go 3x plus 1, right? So it's 3x and then plus 2, which then we subtract. This equals 0. Negative 3 minus 2 is negative 5. So my remainder is 5. And I write the answer by putting this right here. And then I take the remainder here and I put it over the denominator. Because that's what's left over, not denominator, the divisor. And that's my answer. So if I do this times this, I should get this answer right here, and that's what that means. Now there's a synthetic division process, and it just matters in which equation or which one you're comfortable with that you want to do. The synthetic division requires me to change this into an x minus c situation so that I can take c. And I'll show you what to do with c, but I first need to find that. So I need to manipulate this so that x minus c, so this looks like x minus c, basically x is by itself and then minus whatever it is. So if I divide these by 3, I end up with x plus 2/3, right? Because I divide by 3, that cancels out, and then I divide that by 3. But this is also a plus, but I can rewrite this. So this is negative and then negative. So my c is a negative 2/3, and this goes in here. And then I take every coefficient of this. So 9, and then because I still need to put a placeholder of 0 because I don't have an x squared, negative 1 and negative 3. Now essentially these are the same. The synthetic division just takes this and takes away all of the parts that you're like, they line up all the numbers so that basically this is a bare bones, right? So it matters. Sometimes this is confusing for some people, so they like to do long division. It doesn't matter which one. The goal is that you're going to divide it. So from here I do negative 2/3. I'm adding these, by the way, instead of subtracting. So I'm going to take the first number and bring it down, and I'm going to multiply. Negative 2 times 9 is negative 18 divided by 3. So negative 18 over 3 is negative 6. And then this becomes negative 6. And then from here, I'm going to do the same thing, negative 2 times, negative 2 over 3. So negative 6 times negative 2 is positive 12 divided by 3, which is 4. And then negative 1 plus 4 is 3. And then negative 2 over 3 is negative 2. And negative 3 plus negative 2 is negative 5. So because my remainder is still negative 3, but you might be confused on why these different numbers are different. I can still put the denominator 5 over my original 3x plus 2. But these are divided by negative 2/3. And so in order for me to have gotten C, I had to divide everything by 3. So my original answers then need to be divided by 3 also. So 9 divided by 3 gives me 3x, and I start with 1 less, squared. And then negative 6 divided by 3 is negative 2x. And then 3 divided by 3 is, 3 divided by 3 is positive 1. So it's the same answer essentially, just different methods. So go ahead and pause and write this down. And now we're gonna do a problem that requires you to use one way of division or another to then continue factoring problems. Okay, so these are just a method in order to get what we're wanting is to factor more of these equations. So pause and write this down. So in this one, we're going to use our method to then find which ones are factors. And it's only a factor that if my remainder is 0. But the factor theorem states that if I have x minus c, if I plug that in and I get 0, then it's also a factor. So what that means is, if I do x cubed minus 18x squared plus 6x plus 12, determine which one is a factor. So this one is, my c would equal 5, right? If it was positive, it would be negative 5. And then I plug it in. 5 cubed minus 18, 5 squared, plus 60 times 5 plus 25. 5 cubed is 125 minus 25 times 8, which would be 200, plus 60 times 5, which would be 300, plus 25, so 125 minus 200 plus 300 plus 25 gives me 250. So this is not, in fact, a factor. Let's try this one. C equals negative 5. So negative 5 cubed minus 18 times negative 5 squared plus 60 times negative 5 plus 25. This gives me a negative 125. This is a negative, this would give me a positive. This would be negative 200, a negative 300, sorry, plus 25. All right, so I was wondering why neither of them worked. So let's pause the camera real quick. This turns out that this needs to be 450. So then we do 125 minus 450 plus 300 plus 25 is 0. So this is a factor. This is not a factor. This would be a negative 125, and this would be 450 minus 300 plus 25 will give me negative 850. So this is not a factor. So I know then that x cubed equals x, f of x equals x cubed minus 18x squared plus 60x plus 25 can be factored by x minus 5. Right? So pause and write this down. I'm not done yet because I did this part. Check which binomial is a factor. I did that part. But then I need to finish factoring it. So pause and write this down. And then we're going to actually factor it. Now because this is an easy, here I can locate the c as positive 5. I'm going to use synthetic division. So I have 3, 2, 1, 0, so I don't have to put any placeholders. So 1, negative 18 plus 60 plus 25. I didn't have to do the plus. And again, I'm adding these. So I'm going to bring the first one down, which is 1 times 5 is 5. This gives me negative 13. 5 times negative 13 gives me negative 65, which then gives me negative 5. 5 times negative 5 is negative 25, which is 0. So my answer for once I factor it is x, this is x cubed, so I'm going to start with x squared, minus 13x minus 5. That means if I multiply it by what I divided, I should get this. So I need to write this in factored form. Now, you could just do the two divisions here and not try the factor theorem, and then whichever one gives you a 0, then that's fine. It just matters on what your method is. You don't have to do exactly, you just have to figure out which one's a factor, and then once it's a factor, write it in factor form. Okay? So, go ahead and pause and write that down. And try guided practice 3A, 4A, and 6B. And I will see you in class.